Hello everyone, it's my pleasure to introduce three Xilinx Labs initiated works to help mainline the research community to faster prototype SmartNIC and SmartNIC applications. As we all know, it has already been a paradigm in data center that computing is moving from CPU-centric to network-centric, with many successful use cases of disaggregating and offloading functions. SmartNIC plays an important role in this transformation, and we have seen many functions moving from CPU to SmartNIC, like OES, network stack, crypto, decrypto, codec, and so on. The innovation on SmartNIC will continue, but we are also facing challenges to faster prototype our ideas. So in this presentation, there are three works to be mentioned. First, I'd like to introduce our work on implementing common functions of SmartNICs, which we call it as NIC shell. It is a co-work with my colleague Yan and Gordon. Next, a user case on using OpenNIC shell to accelerate permissioned blockchain will be presented. And Harris, G, Mohan, Gordon, and I are working on this. Lastly, in this talk, I'd like to mention an open Xilinx FPGA platform providing open access to academic, thanks to most of our Xilinx Labs and Xilinx University program colleagues to make it available. Okay, so now let's first look into the OpenNIC project. Generally speaking, you can innovate by customizing any function in a SmartNIC. But since it is a NIC, it must have some common requirements. For example, support network ports and plug into PCIe slot. So what we have done is to get all these commonly required functions implemented and provide a good interface for you to integrate unique user logic in a SmartNIC. So in this way, the prototyping of SmartNIC will be much easier and much faster. So keep this concept in our mind. We have designed the Xilinx Labs OpenNIC. And it has the hardware part and software part. Its hardware needs several subsystems of common requirements to support MAC, DMA, registers, and so on. Also, we need well-defined user logic blocks in the hardware with clear clocking structure and interface. And also, it is very important to have sufficient logic and memory resources in the user logic blocks. And a set of utility blocks are used like FIFOs and AXI stream buffers. And obviously, we cannot ignore the driver to make it working as a SmartNIC device. So from this slide, we can see the overview of the hardware architecture. It has several subsystems. The first one is a CMAC subsystem, which supports up to 2 ports, which here we support for 2 QSFP28 ports. It has QDMA subsystem, which supports up to 4 physical functions and up to 2 KQs. It has AXI stream enabled data paths, and it also has the AX Lite enabled control paths. And we can see the user logic box is in between the QDMA subsystem and CMAC subsystem. And we also have a configuration subsystem in the hardware. We can see on top of the architectural diagram. So if we zoom in, we can see more details. And here we can see the blocks in blue are the CMAC subsystem, and the blocks in green are QDMA subsystem. And we have the box in yellow, which is the system configuration functions. And there are two user logic blocks which are in black. In fact, these two user logic blocks are not the same. And in this slide, we can see the difference. The one on the left is running at a lower frequency, but with more interface signals. And the right one is in the opposite. The design is to provide more flexibility to users in practice. Okay, so now you may have a question. How a user logic blocks can be added to the OpenNIC? And here is what you need to do after implementing your customized function in the user logic boxes. You need to implement the AXI stream interface and AXI light interface, modify the configuration of user logic box, and connect it to the reset subsystem. P4 generated plugins can be incorporated, but it is not ready yet in this version. I'd like to mention there are a few early users of OpenNIC in the research community who are playing with OpenNIC in integrating many interesting user logics. Here, I'd like to thank them for their great support and valuable feedbacks. And we tested the resource utilization of the OpenNIC shell hardware on U250 board and Evo U280 board. The result looks encouraging. So with less than 10% logic and memory used by OpenNIC, the rest resources should be sufficient for most of the user customization. And also this project comes with a kernel driver with its design as shown in this slide. Okay, so now we come to the open source resource of OpenNIC shell project. If you want to use it, learn more about it, and contribute to it, please screenshot this slide. The NIC shell hardware and the driver are in two repos because they have two different licenses. And we also have an OpenNIC repo umbrella with the script to check out the latest shell hardware and the driver. And also it has more documents available. Okay, so this is the OpenNIC project. The next one, the one user case using OpenNIC. So this work is to accelerate the permissioned blockchain. This is not associated with cryptocurrency and falls into the so-called permissioned blockchain. We choose Hyperledger fabric as the start point for many reasons. Its consensus is based on energy efficient draft. It is an open source project under Linux Foundation, most widely used one under Hyperledger umbrella, and it is adopted in a wide range of industrials. And in one of our previous papers, we did a profiling work on validation phase of Hyperledger fabric, and we found the performance improvement opportunity to have a software-hardware co-designed solution, which will offload the validation into the FPGA. And you can see the idea from the diagram on the bottom. So there are three main big steps. The first step is to verify the blocks transactions. The second one is to make sure there would be no double spend. And the last one is committed into the ledger. So from the CPU-based solution to software-hardware-based solution, which is on the right, we can see the validation part. Mainly, the first two steps can be moved onto the hardware, namely the SmartNIC. So in this page, this slide, you can see the design. In fact, we put our validation part into the user logic of OpenNIC. And you can see we only use one of the user logic boxes and leave the other one unconnected. And the user logic in the design are only on the receiving pass, and the host will communicate with FPGA through the registers. In this slide, we'd like to pass a message that the blockchain machine is very efficient. The experiment shows a 15 times speed up. Although the results are related to different testing cases, we will usually see around 10 times of performance gain through the offloading of the validation phase into the SmartNIC hardware. And again, we'd like to show the GitHub resource. We'd like to show the document resource for the for the blockchain machine project. We can see you can see more details from this paper available on archive, and we are preparing the GitHub for the blockchain machine, which will be available very soon, and the license will be Apache v2. Okay, lastly, I have one more slide to present our work to provide an open platform for you to implement the FPGA design. So Xacc is known as Xilinx Compute Cluster, Xilinx Adaptive Compute Cluster, which supports research in adaptive computing acceleration for HPC and data centers. There are 4 sites, in fact, all over the world: ETH, Zurich, NUS, UCLA, and UIUC. Each of the sites is equipped with Xilinx Alvo accelerator cards, and we also provide remote access to use these acceleration cards. And here is a link you can see from the left bottom side to join this program. Okay, so I have several summary remarks to end my presentation. The 3 projects are initiated for speeding up the innovation of SmartNIC, or also can be generally computing acceleration with FPGA. They all have a good shape to use now, but there are still many to be enhanced. Take OpenNIC as an example. More board supports are required, as I mentioned in the presentation, and more physical functions like TSO, RSO, scattering are desired. Memory supports will also be useful. So much more important than what I introduced today is coming to use to participate in and to collaborate on these projects. Thank you very much.